For the guys watching video, welcome back to the series. For the guys on live stream, welcome back to the live stream. Okay, so let's start with lecture number 2.5 and let's understand asynchrony. Okay, what is asynchrony? Asynchrony, okay, let me arrange this. Okay, asynchrony basically means that multiple event or tasks can happen independently without being tightly coordinated in time. In JavaScript, this is crucial for building responsive applications, especially in the browser, because it allows your code to handle things like user input, network request, and timers without freezing or blocking. So, suppose a function is currently running and you click on something, that click should be registered and should be considered valid, All right. So let's move forward. The call stack. How does calls work? Function calls in any programming languages are like taking a branch in your code. So you jump to a function, run its instruction, and then return to where you left off. Okay, you have a function. Okay, I did a mistake. You have a function. So you basically jump into what it is, you run what the function does, and then you return where you left. Okay, that is what you are doing. The call stack is a data structure that keeps the track of where you are in a program, especially when the function or the when the functions call other functions. All right, so suppose this is an entire page. So there's a call stack which keeps track of where I am. I can reload this page, I can go back, I can go in front, I can click here to go to school, I can click here to basically go into any of these options, right? But there still is a program that keeps track of where my cursor is basically. All right, each of the each of the function call creates a stack frame. So every call function will create a stack frame. What's a stack frame? Something like this, just in boxes. I cannot draw boxes. I can draw this beautiful caterpillar. Anna, look at this Kamu. Isn't it a cutie? Let's make it a butterfly. Butterfly, 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 butterfly. Where are you going? Where are you going? Okay, I got distracted. Enough distraction for me. So basically a stack frame is made. When the function finishes, the frame is removed. Okay, basically popped from the stack. Okay, and the control returns to the previous function. Example, main calls f. So let me main calls f, then f calls g, then g calls h. The stack buildup goes like main, then f, then g, then h. When h function is finished, h program is finished, you can return to g, then you can return to f, and only then can you return to main. There is no provision given once h is completed for you to return from h to main. All right, that's basically what this is saying. Let's bring this down to the next page. The event and task queue. Java adds two more concepts to handle asynchrony. Again, let's remember what asynchrony is. Asynchrony is basically multiple events or tasks can be basically independently executed without being tightly coordinated in time. Let's understand this line a bit more. What does without being tightly coordinated in line mean? All right, and then we'll increase the pace. Trader. Okay. and do not need to happen one after another in a strict sequence. In other words, tasks can start, run, and complete different at different times without waiting for each other to finish. Okay. So the stack thing is different, and this asynchronous thing is different. Okay. So basically, it means that I have multiple browsers open. Okay, let me open multiple browsers. Let me open YouTube in one. Let me open email in one, and every one of them can work independently without worrying whether the other one is executed or not, right? So let me close this and this. Okay, still there's no uh, effect on the main program. All right. So what does event loop do and task queue do? Okay, so event loop continuously checks if the call stack is empty. If the stack is empty, it takes the next task from the task queue and puts it into the stack to execute. So basically, these two are concepts that go hand in hand. A queue, not a stack, that holds task without waiting to be run. Okay, task can come from user events like clicks, timers, or network responses. How it works? So basically, when a task is running on the call stack, nothing else can run. Okay, okay, just give me 1 second. There is somehow ants biting me. No worries. So when the stack is empty, uh, okay, no worries, no worries. Huh. When the task is running on a call stack and nothing else can run. All right. When the stack is empty, the event loop takes the next task from the queue and runs it. Why? This is why long-running codes like big loops can freeze the browser. It blocks the stack, so no other task can run. Run to completion semantics. Okay. Basically, JavaScript guarantees once a task starts running, it will finish before the next task is picked up. Okay, if you write a code that never ends like an infinite loop, it will block everything else. So how do we check it? So let's say if you have this, then I go to this. Without this being loaded, let's not go here. Without this being loaded, I cannot do anything here. All right, for this hierarchy, for this stack. So once I click on this, once this is completely loaded, only then can I do something else. Let's go to YouTube. Let's go to this. Let's go to how to waste your life. Basically, you get what I'm saying, right? Why asynchrony matters? Okay, let's read why does it matter. All right. I did that this time. There's no numbering here. All right, no worries. So basically, asynchrony deals with two things. One is responsiveness, and the other is user experience. Okay. Okay. So basically, a code which is asynchronous will allow JS to handle slow operations. So there's network issue, your PC is lagging, the code is infinite, and all the other events that can hamper your experience. Basically, it matters. The responsiveness matters. So basically, the code will run without freezing the user interface. All right. Without freezing the user interface, the code will still run. And due to this, the user experience will obviously improve. Browser can continue responding to clicks, typing, and other events while waiting for slow tasks to finish. Okay, so just as we saw here in the YouTube case, everything else is loading, and yet there are some buttons that I can do. See, I can click here. Alright, there are a few things that I can do without the entire page being loaded. Then there's callbacks, the classic asynchronous pattern. A callback is a function you provide to another function to be called when an asynchronous operation is done. So what this means is you'll basically complete a task and then call a function within a function using a function. Okay, so you are using this function to call this function when a given asynchronous operation is completed. All right. So an example, when fetching data from a server, so I'm here at my laptop, I want to fetch some data from, let's say, google.com, amazon.com, and I can pass a callback to handle the result when it arrives. All right. Then there's this node.js, example node.js. Is it not scrolling? Okay. So there are two types of code, that is, one is node, synchronous, blocks everything. So try, so data will fetch something from a txt file and then print it, and if there's an error then the error function will run. Okay. However, in the asynchronous one, both of these will go hand in hand. Error finding and printing of the data inside the txt file will go hand in hand. If there's an error, return the error first and then print the console data. So basically, the synchronous version blocks the program until the file is read, and the asynchronous version lets the program keep running, and the callback is called when the file is ready. Alright, so basically you will get the file when it's ready, when the error is identified. Alright, both of these will run side by side. The event loop in practice. When you perform an asynchronous operation like network request, basically JavaScript sends it off and continues with work. Okay, what does this mean? When operation completes, the callback is pushed onto the task queue. What does this mean? What does this mean? Let's go to Perplexity and ask her to show us. The JavaScript then continues running other code without waiting for the asynchronous task to finish. Okay. When the background task finishes, it pulls. Okay, I will plug in my PC first because I do not want all of this hard work to go to him. Let's not get this hard work wasted. Okay. So when the background task finishes, it calls back the function is. Its callback function is placed into the task queue, also called the callback queue. The event loop is a mechanism that constantly checks if the call stack is empty. If the call stack is empty, then the event loop takes the first callback from task queue. Okay, let's ask it to show me visually to make me understand better. Alright. If this works, I'm a genius. However, this will take some time. Till then, let's go. The JavaScript runs in a single thread, one thing at a time. Okay. Asynchronous is achieved using event loop and callback, not by running multiple threads in parallel. Okay. This design keeps the things simple and avoid many bugs. Modern asynchronous patterns. What are they? Basically, there are two things in the modern asynchronous patterns. Basically, promises and async wait. What is a promise? A promise is a new way to handle asynchrony, making the code easier to read and manage. Where, whereas await, basically the syntax lets you write the asynchronous code that looks almost like the regular synchronous code. Okay, you take away. Okay, so basically call stack, synchronous code, asynchronous task queue, call back here. Okay. Let's solve some questions to understand it better. A plus I, that is comma 10. So basically x is an array, y is another function wherein x dot reduce is used, and inside that a and I wherein a plus I comma 10. So what does this mean? Let's ask GPT again. X is an array, then we have v such that x dot reduce is used, a comma I such that a plus I comma 10, and console.log v. Let's see what does this give us back. Okay, till this happens, let's go on to, okay, there are only two questions. What is run to completion semantics in the context of JavaScript? A task from the task queue will be pushed to the call stack only if the call stack is empty. Okay, task from the task queue will be pushed to the call stack even if the call stack is not empty. The task from the task pushed, the task from the call stack will be pushed. So, okay, so firstly, it's the task from the task queue that is pushed and not from the call stack. It does not go the other way around. So basically, first option is correct. And let's understand the other question. 1, 2, 3, 4. Processes each element. Okay, what this function does is processes each element of array accumulating a single result. It's a function accumulator and current value. Starts at 10, then I1, a plus I11, second iteration 11, I2 13. Okay. So basically adds all of this, adds all of the values here individually and then adds it to 10. That's what this is doing. So in this case 10 plus 21 is 31. Okay, this was easy. However, I do agree that the explanation of this one was not up to the mark. I will try to upload another video for this. Till then, watch this, because this video right here has beautiful visuals which will help you understand it better. Okay, and it's just 26 minutes long. Till then, the live people wait here, and the people who are watching it on video, let's meet in the next video, and I'll try to make that video better.